Hello, good evening, everyone.
Good evening.
Hello, good evening, everyone. Welcome to African Women in GIS West African Zone 7 days masterclass in GIS for beginners. We will be starting immediately. So please, if you can hear me, indicate in the chat box on the YouTube page, then we can proceed. Thank you. Okay. Again, this is African Women in GIS West African Zone 7 days masterclass. And the event is scheduled to hold from today, 21st of June, to 27th June 2021. We are going to dive in straight into the program. But before we start, I would like to give the platform to Omowonola to give us a brief about African Women in GIS. What are we about and what do we stand for? Omowonola, over to you.
Okay, I'm coming. Hello, can you hear me? Can anyone hear me?
Yes, I can hear you.
Okay, I'm trying to share my screen. Yeah, so I'm going to share my screen now. And is my screen visible?
Yes, please.
Good evening, everyone. Thank you so much for joining the training. My name is Omowonola, and I'm going to just be giving you a breakdown of what African Women in GIS is and what we do as a community. So thank you so much for joining the training. So African Women in GIS is a community of women who have African descent and who work or study or have a career in just a special industry. And so the reason why we started the community is just to give a platform for women who have African descent to showcase their talents and to communicate and network with other women who are in the geospatial industries. So I'm going to be giving a brief introduction or history how the community started. So we have our two co-founders, Chidima and Siana. So Chidima had her own community in Nigeria, and she started her own community in July 2017. And Tiana also had her own community in Ghana, and she started her own community in April 2019. So in June 2019, they both connected on LinkedIn, and they felt like there was a need for a larger community of African women to start. And so they decided to merge the two communities and start an, a continent-wide community for women, African women who have a career or who work or study in the geospatial industry. So that's how the community started. So at that time when they came together, the Nigerian members were 41 and the Ghanaian members were 11, and they also had one member in Burkina Faso. But currently now we have over 400 members from over 30 countries globally. So we are not just women, we are not just African women based in Africa. We are a community of African women based anywhere in the world. So if you are someone with an African descent, doesn't really matter where you are living or where you're staying. Once you have an African descent, you're welcome to join our community. So you can see like a map showing where we have our members based. We have people in Africa, we have people in US, we have people in Europe, we have people in Asia. Yeah, so that's like a map showing where our community members are based. So the reason why Siana and Chidima wanted to start the community was because of the issues that were fundamental problems that women or they were facing in their own career. So they felt like, okay, if they were facing those issues, that means there will also be people in Africa that also have the same issues. So they decided to create the community. And as you can see from my screen, they wanted to solve the problem of lack of exposure to African female GIS models. They also wanted to um, solve the problem of the fact that most STEM fields are predominated by men. So they wanted to start a community where women can see other people like them who are doing great things and can motivate them to also build a career in the geospatial industry. And so far our community is 1 year plus, and so far we've been able to do a lot of activities. Like you can see, this training is also like one of the event that we decided to pull out because we felt like because we saw the need for trainings like this to come up so that people can get started in the GIS industry, and we decided to make it open to everyone because we felt like there's a need and we wanted to be the community to bridge that need and feel that need and find a solution for that. As you can see, so these are some of the activities that we've done over the years. We did the International Women's Day webinar. We had Dr. Don Wright from Esri, and we also have Dr. Catherine Nakalembe from NASA. And we also have mentorship program for our community members. So what we do in the mentorship program is that we try to find women, African women or women, any woman, irrespective of where you're located, that has experience in GIS industry and are willing to pass down that knowledge to people that are coming up. So you can see from my screen, these are the locations of people that have been part of our mentorship program. You can see we have from Nigeria, we have from let me from Kenya, we have from other places in Africa, as you can see from my screen. So, all in all, we've created a community for women to be motivated to find a career in GIS, to be motivated to see people who are like them, who are doing great things, so they can also know that they have a chance to have a career in GIS. So, if you'd like to be part of our community, you can check us out on our social media platforms. We have social media, we have on LinkedIn and on Twitter. On LinkedIn, we are African Women in GIS, and on Twitter, we are at African Women in GIS. So you can check that out. They are going to leave that in the comment section. So if you like to be part of our community, you can just fill up our registration, our membership form, so you can be part of our community. Thank you so much once again for joining this training. We really hope that we meet your needs and we are able to help you start your career in GIS. We really appreciate your time and effort for joining this training. So I'm going to pass the baton now to Elena and she can just continue with the training.
Thank you very much, Omowanola. So, like she has briefly explained what African Women in GIS is all about, we would dive in straight ahead into the program of the day. We have different speakers that are going to be talking to us um, on different days for the program. So I'll just share with us a brief agenda of the program for the entire duration. One second. Okay, so I'll introduce the first speaker for the day. The first speaker for today is Olumide. She'll be taking us right through to introduction to GIS. So, Mide, can you take over?
Good evening, everyone. My name is Olufemi Ayomide, and I'll be taking you through the introductory aspect of GIS. Yeah. So before now, I'm sure most of you must have heard GIS, but you don't know what it is all about. Especially here in Nigeria, I'd seen some people a couple of times, actually meeting someone for the first time, and I try introducing myself as a GIS enthusiast. Start hearing something like, "What is GIS?" Like, so it's not funny actually. And I know some of you are here to feed your curiosity. You're also curious about what GIS is all about, what you can do with GIS. And some of you actually know what GIS is used for, like what GIS is all about, but you care to know more. So trust me, at the course of this 7 days training, your curiosity should be fed, and I think the two parties should have their own share of the cake. So let's get down to business. Introduction to GIS. I'm sure everybody can see my screen.
Yes, we can.
Thank you. So what is GIS? GIS, science of where. Esri referred to GIS as science of where, and I think they're actually correct. Because when you talk about your agriculture, you talk about acreage determination, the best of fitting farm area or farmland for your agricultural practices, down to the climatic condition of that area, the soil type, all still boils down to location, like where am I farming, where am I planting. So that is why you'd see, for instance, some crops would thrive successfully in maybe the eastern part of Nigeria, and you have issues with it in the western part of Nigeria. So these are the cases whereby GIS, these are the issues whereby GIS can help you address. So when you're talking about your agriculture, you're still referring to where am I planting? What are the features attached to that location? I'm having my agricultural produce. So down to telecommunication, when you're talking about erection of masts, where it is being needed, you're still referring to where. Where is the befitting place or location for where it is being needed actually. So down to mineral resources, mining of your mineral resources. You understand? Okay, for instance, some mineral resources are attached to a particular location. We have the bitumen in Agbabu in Ondo State, still where and prone to this oil exploration because the maybe the land tends to adjust or is fit for that particular mineral resources. You have your gold mining in Osun State, if I'm not mistaken. All still boils down to where. You understand? Down to your emergencies. Maybe, for instance, there is an accident and you want to know where it actually happened. Nearest hospitals to the site of the events still boils down to where. Down to your crime analysis. Where did it happen? For instance, urban planners would say slum areas are prone to criminal activities or crime activities because most times you have this rugged boys, you understand, that are looking for means to feed. So before you know it, they start indulging in robbery and other sorts of criminal cases. So still boils down to where is it happening? Why is it happening in that particular location? Checking it with the features attached to that particular location. So down to urban planning. Yeah, I want to erect my school. Where is the fit or best fit place to erect my school? Maybe I want to have this shopping complex. You know, all these things needs to be erected in maybe the central business district. You're selling markets and you need people to actually access your products, to buy your products. So you need this particular location, the best fit location to actually erect this building. So down to transportation, still boils down to where population. This population analysis has been useful to, especially in government decision making, policy making actually. So to find out the number of people, head counts in a particular area, so to provide for them maybe social amenities, you understand, and all sorts. So if we are to go by what Esri called GIS, I think actually right, calling or referring to GIS as the science of where. So this GIS of a thing, how did it get started? Like what brought about GIS? Who started GIS? How did we come about GIS? You understand? Okay, fine. Before now, should I say in the 20th century, we've been having problems with different, maybe having problems with agriculture, telecommunication, in medicine, emergencies, and the likes. But I think they must have been solving it the usual way, the regular way. So something brought about GIS, and someone was like, maybe someone just stood up one day and the person was like, this can actually be better. There should be an easier way to addressing these challenges, I guess. So let's look into the history of GIS. There's no way you would mention GIS, talking about the history of GIS without mentioning John Snow. So in 1854, John Snow depicted a cholera outbreak in London, using points to represent the location of some individual cases. So a study of the distribution of cholera led to the source of the diseases, you understand? So a contaminated water pump within the heart of the cholera outbreak. Why the basic element of topology term existed previously in cartography. John Snow map was unique, using cartographic methods not only to depict but to analyze clusters of geographical dependent phenomenon for the first time. So that was how John Snow came about GIS in 1854. So down to Dr. Rogal Tomlinson. So Rogal is actually referred to as the father of GIS. So in 1962, he developed the world's first true operational GIS for the Federal Department of Forestry and Rural Development in Ottawa, Canada. and it was being named Canada Geographic Information System. So we also have our T features. In 1964, we developed a laboratory for computer graphics and spatial analysis at the Harvard Graduate School of Design, where a number of important theoretical concepts in spatial data handling were developed. So we also have Esri that it is now commonly used, provider of the popular ARC GIS software. Yeah, so GIS answers. There are five basic questions which a complete GIS must answer. What exists at a particular location, given a geographical reference? The second question, where can specific features be found? Initially when I was talking and when I was trying to analyze GIS as a science of where, I said there are some particular features attached to a particular location. So where can these specific features be found? Then the trends, what's changed over time? There's this time analysis in GIS, like trying to check the state of a particular community or location, maybe in the last 20 years compared to this present moment, like what has changed. For instance, if you're doing this land use, land cover analysis, so maybe in a particular environment 10 years ago, it used to be a highly dense vegetation area, you understand? So urbanization takes place, sure. So over time, people start erecting their buildings, their companies. You can actually use GIS to depict this, to check the change over time. 10 years ago, this used to be a forest, and now we have buildings. So for instance, if you should have maybe a stranger that would like to get more information about what has actually happened in that particular location, and depending on the analysis he or she would like to carry out. So GIS would help show that trend, what has changed over time. So what spatial patterns exist? We have different spatial pattern. So what kind of spatial pattern exists in that particular area and modeling? This is the higher level application of GIS. So I hope I'm not too fast. Yeah, so definition of GIS. Was it some months ago? Someone asked on the African Women in GIS platform if GIS is a science or a system. So I should be able to like do judgment that now. So GIS as a science, geographic information science, is a science concerned with the systematic and automatic processing of spatial data and information with the help of computers. I hope you understand that, like science, how it is being done. You understand? So the science, how it is being done, what it entails, and stuff like that. The theory behind how to solve spatial problems with computer. So you have to understand the how, the science, else you might not even um, understand what to actually do or how to get started. So before we start talking about the system itself, you should understand the science. You should understand the science, how it works, understand what GIS is by itself. So down to geographic information system is a system designed for storing. Take note of these keywords: storing, this for storing, analyzing, and displaying spatial data. So the GIS system, with GIS system you store, there is another means of collecting data. We'll discuss that later. So with the GIS system, you store, you analyze, and you display your spatial data. So the use of the hardware, software, people, procedures, and the data. So this is the system itself. I think the science would make you to master, would let you master how this are being used, why the system is the features itself, like the component itself, which is the hardware, the software, the people, the procedure, and the data. So on to the next slide. Literal definition. So I tried breaking down GIS for better understanding. When you're talking about geographic, geography, earth, surface of the earth, your environment, and the features, you understand? Man-made features, natural features, geography, relate to the surface of the earth and other features of the earth. So information, knowledge derived from study, experience or instruction. And you can also refer to information as a processed data. So what does GIS do? Or what does GIS do? Yeah, it collects your data and gives you an information, because a regular man that is not a GIS analyst might have issues interpreting a raw data. Yeah, you're given a raw data and what should I do with this? Or you have issues with your farming, your agricultural produce and the likes, and maybe you seek insights from a GIS analyst, and he or she starts saying some things that sounds gibberish, you understand, or start presenting some data you can't even analyze or depict what is actually the denote actually, or you can't even denote what it entails or stuff like that. So GIS help you present this information, knowledge derived from study, experience, or instruction, down to the system. System is a group of interacting, interrelated, or interdependent elements forming a complex whole. Note the word interacting, interrelated, interdependent elements forming a complex whole. Now to the science, the observation, identification, description, and experimental investigation, and theoretical explanation of phenomena. I'm sure most of us are science students, so you should understand what the basics of science is before now. So though I've tried explaining mine as the observation, identification, description, experimental investigation, and theoretical explanation of phenomena. So GIS processes. Yeah, GIS, how do you get started? You have to collect your data collection. How do you collect your data? You can collect your data via field or in-situ mapping using using GPS and other data collection tools. We have some applications like the Google Collect. You can also use Survey 123. We have Q Field, that one is mobile for data collection, field data collection. And we also have the remote sensing method. Um, remote sensing GIS. So we have the remote sensing method. So after collecting your data, after the data collection, what do you do with the data collected? You store, you process, and you analyze using GIS. You store your data, you process, you query. Yeah, you collect the data, then you store, you query, perform some analysis. You understand? If it were to be a buffer analysis, use your GIS tool or software to depict and maybe an area prone to maybe flooding, or to check the availability of some mineral resources in the soil and the likes. So you query your data, then you analyze your data. Then down to the output production, you display your data and your outputs. So you can say this is GPS for data collection, field data collection. GPS would help you collect coordinates of that particular location, so longitude and latitude. Can also help you collect the elevation of that particular area, to check what the topography is, the slope of the area. So, excuse me. So the GPS would help you collect coordinates as I've mentioned, longitude and latitude, you understand, and the elevation of that particular area. And these coordinates, you can actually there's a way you can import them into GIS to depict or to show attributes of that particular location. So the data collected is not a waste. You can still analyze that data on GIS software. Down to your remote sensing method, you can see this is a satellite, and in it has a sensor. We'll talk about the sensor in the next slide. So this is the satellite, and this is the output, your imagery, or um, your map. So remote sensing platform. So I mentioned earlier, you can get your GIS data while field mapping using GPS and other data collection tool. You can also get via remote sensing method. And these are the remote sensing platforms. We have spaceborne, airborne, and ground-based. Spaceborne, that is satellites, optical sensor, and the likes. You might not really understand that, but I'll just give a recap of what it is. So these are spaceborne. I mentioned earlier, it has a sensor. The satellite has a sensor launched into the space. So I think 80% of us should be familiar with Google Earth imagery. So the Google Earth imagery, the information you get from the Google Earth imagery uh, is actually gotten using the satellite platform launched into the atmosphere, sorry, into the space. So it's gotten by the satellite launched into the space. This is the space shuttle carrying the satellites, the space shuttle. So this space shuttle gets launched into the space. Then I don't know if any of you had seen this NASA video of them launching satellite into the space. So with that, you get to understand better. There's this space shuttle like a vehicle that is being used to transport satellites into the space. So we have airborne. The airborne is like I think the most commonly used nowadays is a drone, unmanned aerial vehicle (UAV). So it's like a plane. It has it's like a plane actually. So you can use that to collect data from the heads. So you can use the airborne, which is you can use a plane actually. You can use an airplane, a helicopter attached to it, your sensor, could be a camera, scanner, or whatever. Then your drone attached to it, your sensor to get data of a particular place. And I think recently Nigeria has been inculcating this drone thing into agriculture, trying to get data about agriculture, the vegetation of that particular place, how the plant is thriving, and the likes. So we have the spaceborne, the airborne, and the ground based. So on to the next slide. Remote sensing sensor. Hmm. You have the active sensor and the passive sensor. The active sensor emits its own energy source and detects response. Okay, this is it. We have active sensor. It emits its own energy, then collects an information data from the head surface or that object. It's or that object it's trying to model. You understand that object it's trying to get information from or information about. Then you have the passive has its own energy source and can also get its energy source from the sun. So that's it about remote sensing sensors, the active and the passive. The active emits its own energy and gets data about the objects on the earth, while the passive, some passive sensors has their own energy, source of energy, and can also make use of the energy source from the sun, as you can see here in the picture. Yeah. So to components of GIS. GIS is a system for imputing, storing, manipulating, analyzing, and reporting data. I think we've mentioned this earlier, but it's not bad if I should make it repetitive instead. Just understand when somebody is saying GIS, it has to do with imputing. You impute your data, you store, you manipulate, you query, do some kind of a manipulation to your data. You analyze, then you report your data. So down to the components of GIS. GIS is an organized collection of computer hardware, software, geographic data, procedures, and personnel designed to handle all phases of capture, geographic data capture, storage, analysis, query, display, and output. Still the summary of what I've been mentioning. Okay, so before I continue, if I would like to state if you should have any question, just type it in the comment section. So Inena would help me with that. If you should have any question, so we'd address that at the end of the presentation. So start noting down your questions. If there are other things you are still curious about and I probably forget to mention, just indicate in the comment section, write it down, like type it, and Inena will help with that. So now we move to the component of GIS. We're talking about GIS. It's a system. Yeah, system. So how do I use the system? Then we talk about people. Who are the people that uses this system? Both the GIS analysts, the person that actually handles the data, collects the data, manipulates the data, even down to the users of the data. So when talking about the component of GIS, you mentioned the people. And these are the most important parts of GIS. Define and develop the procedures used by GIS. And people can overcome shortcomings of the other four elements, which is the data, software, hardware, and procedures. People, of course, you make decision on your own. Like you can choose to do whatsoever you want to do, but you dictate to the data. You collect whatsoever data you choose to collect or you'd like to collect. You chose the software and the kind of analysis you'd like to perform with your software, the type of hardware and procedure. So we have the data. Data is information used within a GIS. You understand? Since GIS incorporates data from multiple sources, its accuracy defines the quality of the GIS. So the quality of your GIS outputs still boils down to your data, the data you use. I wouldn't want to start going deep. I would have mentioned, okay, if it were to be maybe a satellite imagery, you might have issues like noise, you understand, haze, and you'd like um, to filter to make the data better. So if the data is having issues, I could remember there was time I was handling a job and the data was having haze, so I was being restricted. You understand? So if your data is having issues, it's going to bring about restriction. Instead, you give a wrong result, or something is just definitely going to be wrong with the result. So you have to be very conscious of the data, the attributes of the data, and yeah, the features of the data collected. So down to the software. Then back to data, we have the demographic data, we have zip codes. Data varies down to your topography, elevation data, and the likes. So those that will be handling the other facilitators that will be handling the analysis aspects would dive more into the data aspect so you understand better. So now let's move to software. Some of you should be familiar with some GIS software, except for the newbies that are just getting to know what GIS is all about. So we have some vector-based software like the ArcGIS, the very known ArcGIS by Esri. Then we have the raster-based like the remote sensing software. We have the EDAS Imaging. We have Envy. We have ILWIS. We have Utrisi. And some people also use AutoCAD to do some vector analysis. But I wouldn't want to dive much into that, so I don't get you overwhelmed. So now down to hardware. The hardware being used, talking about your computer, your keyboard, your mouse, you need a mouse, of course, digitizer, even the internet, the printer, you understand, printer for printing out your results, your output. So those are the components of the hardware. Your computer, your computer, your monitor. The primary school word monitor types of them. Don't let me digress, please. So we have the computer, we have the keyboard, we have your mouse, and digitizer. You have the compact disc, very important because there are some features your computer should have before it will be able to maybe manage some GIS software. So you can make inquiry about that later, or those that are handling the analysis parts can also mention that. So now down to procedure method. Now I have the people, someone that will be handling the data. I have my data ready. I have the software. I have my hardware. So how do I get started? How do I start? What do I do? How do I carry out my analysis? What are the things I'm meant to put in place to get desired results? So those are the procedures and the method. And this procedure too, it varies with the kind of software you might be using. Different softwares has different approach. So whatsoever analysis you'd like to carry out or you're carrying out, you should master the method, the procedure. So these are GIS data formats. We have the vector data and the raster data. So the vector data represents is being represented or represents its features with points, lines, and polygon. You can say points, lines, and polygon. So most times it depicts polygons with buildings. Buildings are depicted with polygons. Then points, for instance, maybe a place, or maybe trees. You can depict trees with points. Then show your line, maybe roads, road network, railways, bridge. You understand? Anything that looks straight, like that looks lateral, straight, just know, okay, depicted with lines. When you start seeing lines in your GIS data or output, you should know for sure it is either a road network, a railway, or a bridge. Then to your point, maybe a forest, sorry, a tree, maybe a tree or a particular feature or substance or a place. You can also denote a place using points. Then your polygon, buildings. If you're looking at the area view of a building, it looks like it either looks like a rectangle or a square. There's this brigade shape. So it depicts buildings with square or rectangle. So these are this the representation of the vector data. So down to your raster data. The raster data is being represented imagery depicting the features about a particular location or a particular environment. Maybe showing the buildings, the vegetations, and the likes. So raster data would help represent that in a pixel format. I don't know if most times if you should, sometimes if you should maybe take a picture and try to start zooming in, you start noticing some boxes. So those boxes are referred to as pixel, and each box has a number allocated to it called digital number. So that is how raster data is being represented. It is being represented in pixels. Pixels, like you understand. So it is being represented with pixels, and each pixel has its own digital number. Okay. So this is the vector data, and this is the raster data. So you can get your data, GIS data sources. We have the S3 Open Data Hub. Uh, I would I would ask, implore one of my colleagues to drop a link to the data sources in the comment section. So you can check, Omo Onola, please help me with that. So you can check the comment section for the link to some of these websites where you can get your data for your analysis. So we have the Esri Open Data Hub. We have natural health data. We have USGS Earth Explorer. Here you can get your shapefile and your satellite imagery. You have the likes of Sentinel, Landsat, Modis, you understand, depending on the analysis you'd like to carry out. So different imagery on different data have different purpose itself. So different image, take note, different imageries and different or different data has different purpose, has different purpose itself. For instance, if you would want to carry out maybe trying to check the land surface temperature of a particular area, the, the satellite data you'll be using or imagery you'll be using will differ from if you're trying to carry out demographic analysis, trying to analyze the population, trying to analyze the population of a particular area. So all still boils down to the features of this data, which are the spatial feature, the spectral feature, the temporal feature, you understand, and radiometric feature. So these are the things you consider before getting to know the choice of the data to use for whatsoever analysis you would like to carry out. So we have the OpenStreetMap. This is a free version of this. So to use this couple of times, and the OpenStreetMap, you can also volunteer on OpenStreetMap, you understand, to have some of this data. So you can sign in as a volunteer and help your community. You can map your community, make data readily available for its use. So we have Open Topography, we have the UNEP Environmental Data Explorer, we have NASA. Of course, I think everybody should be familiar with NASA. When you're talking about your satellites being launched into the space, I don't think you would mention that without mentioning NASA, I think. So we have NASA Earth observations, we have Sentinel satellite data, we have Terra Oculus, and we have Proclaim. So all these websites would provide for you your data for whatsoever analysis you'd like to carry out. And I think they are all free. I think they are free websites. They are free sources. I don't know. I don't. I think yeah. I think they are free. If you would like to, if peradventure you would be paying for any data, that means maybe you want still depending on the kind of analysis you want to carry out. Yeah, maybe you want a maximum accuracy. You understand? You can't afford any flaw, so you can go extra mile to pay for data, so you be sure of what you're working on. Yeah, so we have GIS application. GIS has vast application if you should ask me. Like the application is vast. Just mention that sector, mention that field that doesn't require GIS. Agricultural sector, transportation, urban planning, geology, mining industry, business management, population density, criminology, medicine, and lots more. Now, let me start with agriculture. You can do a whole lot in agriculture with GIS. You can determine acreage, like you can use it for your acreage determination. You can use it for to depict or forecast crop yield production. You can make a forecast of your crop yield. Like for instance, if I should plant in this particular location or in this particular farm site with this particular type of soil, also attached to this particular type of weather or climatic condition, then these are the things I should expect in return. So that is what guys can help you do or can help you with in agriculture. Make forecast about your production, even help you find out disease and pest infestation. For instance, maybe if you know if a plant is being infested, of course, obviously, it's going to reflect in the plants, the leaf, the growth rate, and the like. So these are the things GIS can help you model, and from there, help farmers or agricultural entrepreneurs to make decision. Okay, what are the things I should have done that I didn't do? that led to this. If it is for disease and pest infestation, maybe try using pesticides, fertilizer, you understand. So and lots more we can do with GIS in agriculture. So down to transportation, GIS can help you model the road network of a particular area. The road network, um, I'm sure 90% of you should be familiar with. You start using Google Direction. Maybe for instance, you are going for an event or going to a place you're not familiar with, and maybe you're this kind of shy person, or due to insecurity issues, you wouldn't want to start asking, hello sir, hello ma, can you please help me with this particular direction? Just go straight to your phone or your device, then pop up your Google direction, or Google Map rather. So you pop up your Google Map and it helps you with direction. So that is it with so transportation. Also, you can model your road network. If a particular place has a major roads, or it has a minor road network. So, for instance, maybe should in case of emergency, you would know easy routes to access the close or nearest hospital. You understand? And can also depict the state of that road network. For instance, I mentioned OpenStreetMap. So if you were to be providing data about road network on OpenStreetMap, should in case you have elaborate information. Oh, lest I forget, I'm sorry about this. When I was mentioning data, I mentioned vector and raster. I didn't talk about attributes data. So the attributes data is let's go back to that. Okay, the attributes data is actually the information about this vector data or the raster data. For instance, your attribute data will provide for you, okay, maybe the number of the particular building, you understand, and maybe some features about the building or the environment you get that data from. So that is it with attribute data. Attribute data gives or provide for you more information about your raster data or your vector data. So it gives you more information if you need elaborate information about okay, this data I'm even using. And mind you, some data are readily available. You can get them from some data source, and you can also impute them yourself. For instance, if you had carried out maybe an in situ mapping, like you've been to the field to actually check what feature is in a particular area, and the characteristics, the feature attached to that particular object. Okay. So from there, you can create your own attribute data. So the attribute data in nutshell is more information, gives you more information about your vector data or your raster data. Yeah, so we're talking about the application of GIS. So transportation, yes, help you model the road network. It has to be a path, major road network or minor road network, you understand? And if you're trying to get your route or the route to a particular place, so GIS can help you model that for easy accessibility to a particular location, you understand? So you can make use of your GIS data to access a particular location easily. Last time I went on a field work and I have my map. So, just place the map, and mind you, your map must not be turned upside down, else you would miss your way. So I have my map, and so it's just very easy for me to access places where I need to access. Instead of me start asking, you understand, is how can I locate this particular place? I have my map. So my map was able to tell me, okay, this is the road to this particular place. This is the fastest route. This route is a bit long. If even your attribute data should be able to explain to you the distance from one particular location to the other. If you want to go extra mile, you can add distance. You understand? So with my map, I was able to depict, oh, this is the fastest route to we are going to. This is a bit long, and this is where the roads are meeting. This is where the roads are meeting. So down to urban planning, urban planners should be able to relate better. I mentioned earlier, for instance, if you want to erect a school, for instance, you want to erect a school, okay, you have to find out where it is most fit or best fit for the erection. You can't erect a school beside maybe an industrial building. You understand? Maybe the noise from the industry would start affecting the students, stuff like that. So these are the things GIS can help you model to check the best fit or best location for a particular place. And also in urban planning, you can check how compacted a particular location is. If it is too rowdy and maybe you want to carry out some planning, you understand, or if it is well planned, like the estate, you understand. And also in urban planning, you can check, okay, slum areas and also estate, yeah, mention that. And also, yeah, the best location that is fit for a particular building erection. If it were to be a residential building, where it is supposed to be. If it were to be an industrial building, where it is best fit, you understand? That one, it won't be detrimental to another building features. And was it recently I bumped a friend's WhatsApp status that was mentioning this issue of having petroleum station, oil stations within residential area, which is very wrong. Just imagine if there were to be a fire outbreak, the number of lives that would be at stake. So these are the things GIS would help you model, you understand, to check where is best fit. I think there are some rules and regulations, there are some law guiding each urban planners will be able to relate better. So there are some laws guiding each building, residential building, industrial buildings, commercial buildings, and the likes. So down to geology, GIS can help you depict or model uh, the geological features of a particular area. Down to your mining, I mentioned earlier, some resources, some natural resources are actually attached to a particular location, maybe due to the physical or biological features of that particular area. So down to business management. For instance, if you want to start a business and you're trying to find out the number of people you will be feeding, maybe find out the population density of a particular area, and if your business target, if the target is maybe um, working class, so you can actually use GIS to depict all those things. It would help you with proper planning so you don't overdo or overproduce and on the long run be at loss, you understand, or you start having waste products or stuff like that. So it could help you with your business management. Then population density, I mentioned earlier, this population density is very has been useful to government or policy making, has been useful in policy making lately. For instance, in the government sector, if you're trying to plan maybe, okay, if you're working on a social amenity, for instance a hospital, so you would want to know the number of people in that particular area that will be entitled to that social amenity or that facility. So if you don't know these things, you would have issues. That's why you see sometimes some hospitals would have limited space or limited beds. Because if your targeted persons were to be for that particular community, then you should have an idea of the population density of that particular area. For instance, just imagine what happened recently about this COVID-19 pandemic, and some hospitals ran out of bed. So all these things should have been provisions should have been made for all those things if the government were to be aware of the population density of that particular area. So I'll be rounding up soon. So down to criminology and medicine. So about criminology, I mentioned some areas are prone to crime, e.g. slum areas, because we have highest number of students that, I said students, we have highest number of people that are poor, they can't afford to go to school, and if somebody is not schooling, you're not learning work, you're not doing anything, you would definitely be doing something, and hence they start indulging in crime. So slum areas are prone to crime, and you can depict that using GIS. Why you can actually check the number of crime cases and a particular crime. For instance, those time we're addressing rape incidents. So if you should notice, okay, a rape incident has been happening here over and over again. What could have been the problem? For instance, if it were to be an area, maybe a rural area that has a lot of bushes, you understand, you won't that has maybe a lot of bushes, and maybe a teenage girl is trying to go to the stream or just go out on his or her home um, or without working with someone, maybe just going there alone, and someone just accost her and just push her to the bush and rape her. Cases like that. So all these things are have effects. All these things have effects on crime analysis. Then down to nearest police station. You understand? If there are enough police stations or organizations handling that particular crime in that particular area. So down to medicine, in fact, this was what birthed GIS in the first place. Remember the story of Jon Snow? I told you how Jon Snow was able to address cholera outbreak with GIS. And we have other GIS application. So I would drop here and give the space to my other colleague, Omowonola. She'll be taking you through um, sources, GIS data sources, and giving you more like elaborate information about GIS data. Thank you.
Um, Thank you very much, Mide. Um, we would like to give the floor to Mowanola, who would be elaborating more on introduction to GIS. Mowanola, are you ready?
Yes, thank you so much, Elena. Everyone hear me?
Yes.
Hello, can anyone hear me? Yeah, okay. So I'm going to share my screen now. Is my screen visible now?
Yes, please.
Oh yes. So thank you so much, Mide, for that. That was very insightful. So like Mide shared before, so I'm just going to be showing us. Mide has talked about vector and raster data, and I'm just going to be sharing with us some websites where we can get to download these data sets and how to go about it. So I'm okay, I'm going to navigate. Can everyone hear me, please?
Yes.
Okay. Yeah, thank you for that, Nina. So this is the website. Nina is going to be sharing the website in the comment section. So I'm just going to copy the URL to the website now. I'm going to share with Nina. She's going to share it in the comment box. So this is one of the website where you can get vector data. And like I can see in the question in the comment section, somebody asked the difference between a raster data and a vector data. So you are going to be seeing the difference between those data sets live like now. So this is data.omdata.org, and this is one of the places where you can download vector data. So you can filter out your data. Like if you come here, you can see you can filter out your data, you can filter out your location, you can filter out the format of the data you want to download. It's CSV, is it doc, is it document, is it these are like all the some of the GIS data formats. Is it JSON, is it KML, is it GeoTIFF? So you can also filter out based on the organization you want to download the data from. So there are a lot of organizations that provide data on this website. You can see Bill and Melinda Gates Foundation. You also see World Health Organization. Yeah, you also see World Bank Group, World Food Program. So there are a lot of organizations that contribute data on this website. So if you want to filter out the data you want to download, this is you come to this tab beside this place and you filter based on what you want. If you want to download just administrative divisions, you come and pick. So you just click on the data you want to download. Say if you want to download administrative division for say, okay, sorry, for say, okay, my laptop is hanging. Say Afghanistan. Can you see? So for Afghanistan. So I want my format to be CSV. So I want the data to come from, I don't know why my laptop is hanging. Yeah. So it will be you will be able, you can see, okay. So it's normally going to show the result of your filter in this place. But the way I normally go about it is if I want to download data, if you don't want to filter out the data set, because sometimes you don't know which of the organization has the data, which data set. So you can just come here and just type. So if I want to download, say I want to download population for Nigeria. I hope everyone can hear me and see my screen.
Yes, we can.
Okay. So you can just say population for Nigeria. So once you type in the your search text, so you can just okay, just press enter, then it's going to load. Yeah, so okay. So these are the you can see these are the organizations that has the data that has to do with population for Nigeria. You can see UNFPA. You can see the number of downloads, 7,200. You can see the last time this data set was updated, 18th June 2021. You can see the data set date. So this data set is from June 18 to June 21. We can see the update on how often they update the data set. So they update this data set every year. So maybe they update it every June of every year. So this data was recently updated, and you can see they gave like a little description of what the data set is, the reference year, and you can see the format that they have. They have it in Excel format, XL, SX, and CSV. You can see this word population. They have their own format in GeoTIFF, and you can see they have 40 plus downloads. I mean, yeah, 40 plus download. The last time they updated the data was last year, November 24, and the data set is from January 1st, 2000 to December 31st, 2020. So you can see a lot of organizations that contributed data to this organization. So you can see also group three, they have like their own data set, and they have this number of downloads. They update the data every year. Okay, so these ones they update the data as needed. And the last time they did an update was 27th January 2021. You can also see, so we have a lot of organizations that has provided data that has to do with Nigeria. So let's say I want to, let me see. Okay. So let's say I want to, because this one has the highest number of downloads, I feel like, okay, let me download this one. So you just come here, you click on the data set. So you can see the chart showing the number of downloads, when people downloaded, what month has the highest download. I think this should be February. Yeah, this should be around January. Then this, okay, June. Yeah, you can see all this. Okay. So these are the data sets. You can also read the metadata of the data. So the source is UNFPA, contributor is UNFPA. You can see location Nigeria. You can see, so it's public. You can see the license. Yeah, so you can see all this stuff. So now if you want to download the data, just come to the data resources and just download any one you want. So let's check. So this one is Nigeria admin boundary tabular data. This is population. This is population. This is population as well. And yeah, so this is how you just come to the website. So you just type anything, any data you want to type in the search data set here. So if I want to download say health, or let me say for Zambia, if I just type Zambia here, bring out all the data set they have for Zambia. You can see prices, subnational administrative boundaries. You see the contributors. This one is FAO. You see infrastructure trade. This one's from World Bank. This one from World Bank. Poverty. So once you so if you say you don't want to download the CSV format because you know that is a tabular format, this one has a shape file, has the database, so you can just click on it. Yeah, okay, because this one has a shape file, so you can definitely see like a web map base of the admin boundary of where the data is covering. So you can decide to download the Excel. This is shape file. You can see this is EMF. So it depends on the data format you want your data to be in. So that will determine which one you download. So they always have multiple data that you can go through. So it depends on the format you want. So if you want it to be in a tabular form, if you want it to be in a shape file. So the person that asks why using Python is recommended in GIS. So imagine that I have this data set in tabular form and I want to run some analysis on it. If let's say like this data now contains like two 3,000 data sets. So Python just makes it easier for you to automate your analysis because normally if you want to do analyze this tabular data, you have to check through it, you have to clean the data, you have to do all sort of things on the data. But what Python does is it makes it very easy for you to be able to visualize your data without having to do it manually. You can filter out some data. Say, like say you have a tabular data, you just want to because I don't really know much about Zambia. So let's say you just want to check the population for a particular state and not the local government in that state. So it just makes it very easy with Python. You can call the state and call the local government. So it depends on the column and rows you have in that data set, by the way. So let's say you have a column that says state, and then you have a column that says local government, because that's what we use in Nigeria. So if you filter out, say, a place in Zambia, you can also like easily filter out all the local government that falls in that state using Python. So Python just makes it just automates the data analysis part and data visualization part of the GIS process. So that's why GIS analysts are always recommended to at least learn Python. So if you want to download your data, just click download. So it's just going to, so you can see it's already downloaded on my laptop. So if I open it, so sometimes my laptop can hang. So I'm just going to, so if I open it, so if I open it now, so my laptop can be very, yeah, you can see the data sets. Yeah, so imagine if you want to process all this data now, like let me see, it's just one system. So yeah, so this is the data set in tabular form. So you can do your analysis with this data set. You have the area, the shape, the the date, the admin name. So I don't really know much about Zabbia, so I can't really say what these things are. But if you know about Zabbia, you know what these things are. Yeah. So this is the data set. So I'm going to close now. So I'm going to go to it. Can you see the Excel sheet? Hello?
Not yet. Not yet. We can't
Okay,
see it.
sorry. Oh yeah, because I'm only sharing. Oh, okay. I know why. I guess. Okay, so I, I have to stop sharing my screen and then share it again. But let's just move on. So I'm going to go. I want to stop sharing my screen so I can share another tab on my Chrome, and we'll move to the next website to download datasets. So this, okay, yeah. So I'm going to just give me a few minutes. So yeah, I'm going to just give me a few minutes. I'm going to Can you see my screen? Please let me know when you can see my screen. Is my screen visible now?
Yes, we can see. Yeah,
Okay,
data-driven
so this is
decision making.
okay. So you can see grid three. Yeah. Can you see grid three?
Yes,
Okay, that's perfect.
yes, we can.
So this is another website. Okay, thank you so much. So this is another website where you can download data, but this is African based. Yeah. So we are going to share the website for you in the comment section of chat box. I'm coming. Okay, so yeah, so this is grid three, and yeah, so this is another website where you can get data, but this is African based, and this grid three is a project that is supported by Melinda and Bill Gates Foundation and the UK AID, yeah, I guess. So what they're trying to do is, yeah, so you can see. So what they're trying to do is they're trying to make data accessible for people, for users. So they work with government to gather data that are useful for users in Africa. Or if you're working on a project that has to do with Africa, you can just come here. You'll also be able to get data. The website I showed before also has some data from this grid 3. When I was explaining, I saw some data set from grid 3. So if you like to navigate through the website more, you can do that. But because of time, I will only just go to the how you download data from this website. So when you come to resources, you will see data here. So it's loading. Okay, so these are the data teams for the data that they have. So they have data based on population, based on settlements, based on points of interest, based on boundaries, based on physical distancing. And so these are the countries where the data are available. Okay, okay, this for the population. So if you want to now like download data on this website, you click on any of the themes that you have interest in. Say I want to download data, say point of interest. Say maybe point of interest are data like maybe hospitals in a particular area, say churches, say schools, say banks. Yeah, so I just click on it. So when you click on it, it loads down here, so it doesn't take you away from this page. So what you now do is you come to this country available, so it shows you the countries where they have this interest, this data that has to do with points of interest. So when you click here, you see they are for Democratic Republic of Congo, and for Nigeria, and for Zambia. That's so if I click on settlements, it will also load. So you see the countries where they have the data. You can see that the countries here are more than the ones for the points of interest. So that means they have, for settlements, they have a lot collected, lots of data on settlement for a lot of um, countries in Africa. So you can see it has version. So when you see version 1, maybe this is the first time they collected the data. For some, you will see, okay, if I click on population, you check the countries where they have this data
Sorry,
set.
we can't see.
You can see that you can't see my screen.
We can't see where you are selecting the data from.
Okay. Can you see my screen? Can you see the grid 3 site?
Yes, we can. We can see the grade 3 site.
Okay. Okay. So let me start all over again. So if you want to, okay, so let me go to home. So okay, it's this thing. Yeah. So this is the landing page for the website. So So if you want to download the data, you come to resources, you can see data. So you click on the data here. So it's loading. So once you click on the data, it brings out these 5 things. So these are the data set they have. They have data sets on population, they have on settlement, they have on point of interest. So if I want to get data sets, let's say I want to like get a data set on settlement. So if you want to get, you click on settlement, like it will not take you away from this website. I've already clicked on it. Like what happens is so fast that you don't see it. But once I click on settlement, automatically it updates this place with the countries that they have the settlement data available. So you can see. So if I click on population, you don't see what happens. But once I toggle on it and I click on it just once, you see that it changes the color to, it changes from yellow to like orange. So it's showing that I'm on this data set. So once I do that, it also changes. You can see the following population data sets are available through the World Open Population Repository. So these are the countries where they have the population data set available. If I click on boundaries, you see that it changes to this color. And if you read the headline here, okay, they
Please,
didn't put any. You can see that they only have, and you can see
Omonola,
the data set says, yeah. Am I too
sorry to
fast?
cut in. Sorry to cut in. I think no, not exactly, but we are not seeing what you are selecting and what you are sharing. So some people are concerned. They actually want
You,
to see what you are clicking and
wait, you
selecting.
don't see my screen.
But we
Is it
can't
that you
see.
don't
We are
see my
only
grid
seeing the
3?
Grid 3 website. We can't see your selection.
Sorry,
Yeah,
I
we
don't
are
miss.
seeing the Grid 3, but I think when once you select something or click on a menu, yeah, we can't see.
Nina. Okay, so let me be sure that I'm actually. Do what you see now? You see the home of grid 3, right?
Yes, we are seeing the home of Grid 3.
Hello, Nina. Hello,
Yes, we are seeing the home of Grid 3.
hello. I can. Okay, and you can see that it has moved to the data. Can you see the population settlement, point of interest, boundaries, physical distancing?
No, please, we can. I think when once you click that, we don't see it. So maybe they can take their time
Okay.
to check the Grid 3 website by themselves because we can't see it when you click yes.
Okay,
Okay,
maybe
now
let me.
yes, we can see
Okay,
now.
sorry. Let. Okay, yeah. Okay, I know. Okay, sorry. I was using another. Oh my god. Sorry. Okay, you can see now. Sorry, that was a mistake on my part. Can you see now the data? You can see the data resources. Hello, hello, Inen, are you there?
Yes, we can see it now.
Okay, yeah. So, like I said, oh, like sorry about that. I shared the wrong screen. Yeah. Okay, so you come to resources and then you see the data here. So, like if I go back to the home, so this is the home. You come to resources and then the data. So you get all the, so these are the things I've been saying since. So you see population, settlements, point of interest, boundaries, physical distancing. So once you click on any of the data set that you want to download, you can see for population, it will show here. You can get the number, the countries where they have the population data sets. So you can see the following population data sets are available through. So for these countries, they have the population data set for this country, for Burkina Faso, for Mozambique, for South Sudan, for Nigeria. So they are still like updating and trying to work on the data set. So I feel like very soon they'll have more countries for this. But if you click on the settlement, you'll see they have a lot of countries that they have the data on settlement. So that's how you get the data from this website. So also if you click on points of interest, you see the countries where those data are available, where they have them available, just Nigeria, Zambia, and Democratic Republic of Congo. So this is how you download data. Say I want to download the data on settlement for let me use Nigeria because I'm from Nigeria and can available. So like I said, they update the data sets. So you can see settlement, and this is version 1. So maybe when they update or when they add another data set that has to do with settlement, maybe you have a version 2 for that. So just click on settlement and it takes you to, yeah. So you see, it takes you to all the data they have on the settlement. This is Abia, churches, their built up areas, dump sites. So you can actually search. So if I say I want a data that's in Lagos, I can just type Lagos here and then it just brings the Lagos ambulance, Lagos churches, Lagos dump sites, Lagos, and you can see the data type GeoJSON, GeoJSON, GeoJSON. So they have most of their data sets in GeoJSON. So you can see they have a lot of data in Lagos, hamlets, laboratories, markets, mosques, healthcare facilities, primary, secondary, and tertiary. They have government buildings, fire station, filling stations, farmlands, all this kind of data set. So let's say I want to download a data set on mosque in Lagos. I just click on the data set, and you can see they also have their own metadata here. So they created the 2020. So they have the coordinates of the, maybe the boundary of the Lagos. Then you have, if you want to like contact them, then you have some other data set that can, yeah, okay, spatial reference. So they have some other type of information that can let you have understanding of the data set and how it was generated. So this is activity stream. They don't have anything here. So if you want to download this data set now, you just toggle this thing on, and then you click download resources. So it's already downloading. So yeah, so it's already downloading on my laptop, but you can't see the download because I'm sharing just one tab in my Chrome, and that's the only thing you can see for now. But it's already downloading on my laptop. So that's how to download the data set from this website. So these are all vector data sets. So now I'm going to now go to a place where you can download raster data sets. So you see um, the difference between the raster and the vector data sets. I feel like by the time we move on, you'll be able to see them like and understand it more by the time we move on to the next session, or by tomorrow, the next day after tomorrow. By the time we move on to the analysis part, you'll be able to understand the difference between the vector data and the raster data. So these data are vector data. Yeah. So now I'm going to stop sharing my screen and share my screen again to another tab where you can see how to download raster data sets. Okay, so I'm going to stop my screen and share again. Okay. Elena, is my screen visible, please?
Yes, it is.
Elena. Okay, so this is a raster data. And how do you see that this is a raster data? So if I zoom into this now, it's very high for this. So what makes a data a raster data is that is pixel based. So if to say I can zoom in more into this picture, you see that all these are pixel. If you check your phone and you take a picture on your phone, you zoom your picture to the highest resolution, or you zoom it in, you will see that all the things that make up that picture, they are pixels. So you can see them in like box. So those are what makes up that picture that you see when you don't zoom it in. You just see your picture, you see that you're wearing a fine clothes, or you just see your head. But by the time you zoom in, you see that all those feature you see all at once are made up of very, very small little pixel. So that is what a raster data is. So they are pixel based, and so the reason why we always try to use vector data. We can also analyze raster data set, but it makes it very easy for us to be able to measure the features and do some other stuff and be able to analyze and use the vector data. It's easy to use the vector data more when it comes to doing analysis than using raster data, because you can see now this data set is, I can't manipulate it, I can't do anything to it, I can't move this building, I can't do anything. It's already there, it's fixed, so there's little I can do to it. So but with the vector data, by the time you will be able to learn that in day three. By the time you digitize this feature out, you'll be able to do some manipulation and be able to create maps from all those data sets. So, like I said before, by the time we move on into the training, you'll be able to understand more on what is a raster data and what vector data is. So, this is a raster data, and I think, let me see where. This looks like, I'm not sure, maybe it's a Google Earth imagery. I'm not really sure. So this is you. Okay, let me share it again so that you can, if you want to check the website out by the time you're done with the training, you can do that. So okay, so if you want to now download data from this website, okay, so this is how you do it. Because I'm not logged in, because of time. So just to show us how we can easily like download data from this website. So I'm not logged in right now. So there are little things I can do with this. You can see you say you must be logged in to upload the file. So if I want to say I want to work on this particular area, let me say this is Abuja, this website Abuja. So okay, let me show you how the image was before. So this is what you get once you come into the into the website. So because I wanted to work with Nigeria, so I zoomed in. So you can see, I can see places in Nigeria, Kano, Rizal. So let's say, let me zoom into Lagos. I think everybody is familiar with Lagos. So this is Lagos now. So you can see Lagos, Apapa, Surulere. Yeah. So before you can be able to, the reason why you can actually see that I have clear images because my internet is quite good. So before you can actually be able to have this very clear imagery, you need to have like very good internet. So say I want to work on this area. Say like I want to do I want to analyze, I want to do an analysis on this area. So what I'll just do is I'll come to, I just I'm using a mouse, so it's advisable for you to use a mouse. So just click on the point or anything that will form like a boundary for your area of interest. So because I'm just making this up, it's a pseudo area of interest. So you draw like a polygon around your area of interest. You can see I'm just placing it. What all you have to do is just put your mouse on the area you want to use, and just right click. It will just drop the polygon for you. You can see that once I created my boundary, yeah, it already like put the coordinates in this place. So another way that you can do that is you can maybe upload a file. Say maybe if you have a boundary of a particular place and you already have the shapefile of that boundary, so you can just upload it here. So it just brings it in and puts the boundary in the particular place that it falls on. Exactly. So, but because I'm not logged in, I can't do that. So you can see, so this is my area of interest. So I've already drawn a polygon around my area of interest. So if you know the coordinates of your area of interest, you can add it by adding the longitude and latitude. So you don't have to do this drawing. So it depends on the method you want to use. But because I'm not actually particular, I'm not exact about I'm not doing any analysis, so I don't have to pick an area of interest that I don't have to be accurate with the area of interest I'm picking. So I can just draw a polygon around it without having to concern myself or be worried about whether it falls on because I'm using a pseudo area of interest. So once you are done picking your area of interest, okay, now I want to do my analysis on this area. Say I want to check for the NDVI for this area. Okay, you will learn that too. Or I want to do a land use land cover analysis of this area. It's a small area of interest, so definitely. But let's say this is Lagos, and I want to just check the land use land cover of Lagos. So I'll just draw my area of interest like this. So, and one thing, because satellite sensors, or yeah, they are in space, and they they've some have been launched for a very period of a long time. So you can actually specify the range of the dates you want your data to fall in. Say I just want to work on data set from, let me just use the date here, from 2018 till 20, like from 6/8/2018 to 20 June 2018. So I can just pick the date, year. Yeah. So when I pick the date, so I will now go to this data set. So this is where you get the type of data set that you want. So we have Landsat, we have Sentinel, yeah, we have UAS, but I'm not sure if you can get access to all these data sets. I'm not sure if you have to pay to access some of these data sets, but I know for sure that if you click on this Sentinel, say you want to work on Sentinel 2 data, you just click on it. So this is the data set I want to download. I want to download a Sentinel-2 data that falls in my area of interest from 8/6/2018 till 26/2018. So that's what I'm telling this thing, that help me to filter out the data set, because they have a lot of data sets from a long period of time. So help me to filter out a data set that falls in this location from the particular date I picked. And okay, so I can add additional criteria to my data. So, okay, so I can say, okay, I want the cloud cover to be less than 20, or less than 30, or or less than 100. So it depends on the kind of analysis that you're trying to do. Mhm. So you can leave out the rest, or I don't really use all this stuff, so I'm not really sure about them. But what I know that I usually work on is the cloud cover. That's always one. But if you want to read more on this, you can definitely do that. So now I go to my results. So it's searching the my okay, I hope my internet. Okay. So you can see it doesn't really show anything, because I picked a very old, maybe because due to my filtering, the data I picked during my filtering, so it didn't really capture much data. But this is actually how you go about it. So you check for the data set you want to use, the type of satellite imagery you want to use. You check for the year you want to download the data. Is it 2020? Then you now also do the cloud cover, and then you go to your result, and then you're able to see it. Sometimes it brings out over 20 data set that you can just pick from. So you go through the data set, and you see, like, I've seen this one, I don't really like this one. So if to say that I had a lot of data sets here, I can just pick them until when I find the one that I feel like, okay, I can work on. So once you do that, you just come here. You see, say log in to download sim, but because I'm not logged in, I can't download. So once you click login to download sim, you will be able to follow the processes to you'll be able to follow the processes to download the data set. When we start our image classification, when we dive deeper into our remote sensing aspect of the training, you will learn more on how to analyze this data set, raster data, and be able to make infer insights from your analysis, and be able to see what is going on in a particular area from your analysis. So I think those are the three websites, because of time, that will be showing us today. Do I have any questions I need to answer before I stop sharing my screen? So I'll just stop sharing my screen now. Okay. Nina.
Yes, please, I'm here.
Okay, yeah, sorry, please. Okay, you said I should stop. I just want to show one last, because of time. I feel like maybe moving forward, maybe like when we proceed in the training, we'll be able to share more on we'll be able to learn more on this. Yeah, so thank you so much.
So, thank you very much, Amawanola. That was a very insightful training. I want to use the opportunity to apologize to our viewers because of time and the curriculum or courses say that we have. We are constrained in regards to time, so we are trying as much as we can to see how we can unpack all these things because our target is basically beginners. And if you look at our curriculum, it's so packed up that I'll be sharing with you. This is our agenda and the topics we are aiming to cover. For the day one, we are looking at introduction to GIS, data types, and how to acquire them, which Mide and Moonola has already touched base on. And for tomorrow, we are going to look at familiarizing with the software. So we are looking at QGIS. There are other softwares you can use for GIS analysis, but we're looking at QGIS because QGIS is basically an open source software. You don't need to pay for it, it's free. So anybody can have access to it. Then we will touch base on GeoDatabase tomorrow. Then on day three, we are looking at georeferencing, digitizing, and creating a map. And day four, we are looking at introduction to remote sensing and image classification. Then day five, we are looking at buffer analysis and hotspot analysis. Day six, we'll be covering land use, land cover, modeling. And we are also going to be looking at hydrology on day seven, hydrology and watershed analysis on day seven, and NDVI for vegetation on the same day seven. And if you look at the way the curriculum is structured, this is basically um, like a full master's course. I bet if you are able to follow us from day one to day seven, with if you have a BSc, I think you can even migrate to PhD. So we are trying as much as we can to see how we can provide this training for the 7 days. We know it's going to be stressful, but we are pleading with our viewers to try as much as you can to follow the program from day one, which we have already about to conclude now, up to the last day for the NDVI for vegetation. So the program starts at 6 p.m. every day and ends at 8 p.m. This is because we are looking at people who are working so that they will be able to have time to partake in this training. So from tomorrow, where we'll be looking at the software, we are using QGIS. We have pasted the link on the YouTube uh, live video comment. You can see the link here on my screen where you can download the software so that you can also see if you can follow with the practical sections from tomorrow henceforth. It's better to have the software and you can practice alongside. Then for the time, the 6 p.m. is GMT plus one is Nigerian time for, because we have people who are not only Nigerians, we have people across Africa who are joining this program. So it's 6 p.m. GMT plus one every day. And the training is free. Please, it's a disclaimer. Don't allow anybody charge you for this. We are trying to give this training free as our community service. So it's free of charge. And at the end of the training, we are going to be giving out certificate of participation to all the registered members for this program. So we have a criteria. We have a little bit criteria for the certificate. So the criteria is that after the section, we are going to be giving out like a follow-up assignment. It's not going to be very tasky, but it's just going to be what we have, done throughout from day one to day seven. We are going to be giving out some assignments for you to do so that we'll see how we can we can measure the impact of the training we are offering to our viewers. So on your submission to the assignment, we would be able to give out the certificate. The certificate is there, the certificate is for everyone. So we would encourage all our viewers to try as much as they can to participate. Get the QGIS downloaded on your laptop. This is the link. It's also on the YouTube comment, so that from tomorrow we can have practical live sections on it. So please, Omo would like to make a comment. Omo, please, over to you.
Yeah, thank you so much, Inena. So I just checked through the YouTube comments and I saw that people were debating about Python programming language, if it's a data format or a programming language. If I'm not sure if I made mention of that, but if I did, I was probably carried away by what I was saying. Python is a programming language, just like JavaScript. I probably made a mistake because I was, yeah. So when I was talking about data format, I was talking about CSV and XLS and GeoJSON and Shapefile from the first website I showed. Please note that Python is a programming language and is used for automating tasks. So thank you so much.
Okay, thank you so much, Omowonola, for clarifying that. We are trying as much as we can to pick the comment section. We have 9 minutes left for the section. We are trying to pick all the comments from the comment sections, and we would be answering the questions to us from tomorrow or after the section. We'll compile all the questions and answer for the comments that are coming in from the viewers. Then I would like to answer, I think somebody asked a question about how GIS can be used in animal tagging. So for animal tagging, GIS and remote sensing can be used in locating the animals. When it comes to coordinates, you can tag the animals with GPS so that you can track their movement, you can understand their migration pattern, because if they have a GPS, you can know at from one point to the other, this is where they start from and this is where they move. So you can be able to understand their migration pattern. You can also map the route they use for insight. So GIS is a very huge science. Somebody was asking, is it only for science? No, when we mean science, it's not just science as a subject. So GIS can be used in all sectors. Facilitator from the beginning, Mide highlighted it. It can be used in the agriculture sector. It can be used in the transportation sector. It can be used in the geology sector, criminology, health, medicine. It can also be used in the humanitarian sector. So mention it, GIS can be used in anything you can lay your hands on. So I would like us to call it a day now. So from tomorrow, we'll QGIS and Geo-Database. So I would like to appreciate you for being with us. It's 2 hours already. So I would want to extend my greeting from African Women in GIS and the West African Zone. We are grateful and we look forward to seeing you from tomorrow. So please don't forget to download the QGIS. Very important. This is the link here. Check on the YouTube comments. The link is also there. So I think that is that for the day. So thank you so much. If you have any question, you can also reach out to us in the email address where we responded to the training invite. So thank you. See you tomorrow, 6 p.m. GMT+1.